In the summer of 1955, a test pilot named Tony Levier climbed into the cockpit of an aircraft that did not officially exist, at an airfield that did not appear on any map, for a program that the United States government would deny for decades. The aircraft had no weapons, no armor. It was painted black, had the wingspan of a bomber but the weight of a sports car, and looked less like a military machine than like a glider someone had accidentally fitted with a jet engine. It had no wheels on its wings. The pilot had to balance it on a single center line of two wheels like a bicycle, while chase cars raced down the runway calling out altitude corrections. That aircraft would go on to photograph the entire Soviet nuclear arsenal from 70,000 feet. It would discover missile bases that the Kremlin swore did not exist. It would prevent a nuclear war over Cuba. It would trigger the most humiliating diplomatic crisis in American Cold War history, and it would still be flying 7 decades later, because no satellite, no drone, and no technology invented since has been able to fully replace what it does. You have almost certainly heard the name. But what you do not know is what it cost to build, what it took to fly, and why the man who designed it did it in 8 months, with a slide rule and a team small enough to fit in a single room. But first, you need to understand what the United States could not see in 1954, and why that blindness nearly ended civilization. After the Second World War, the Soviet Union sealed itself behind what Winston Churchill called the Iron Curtain. By the early 1950s, American intelligence agencies knew almost nothing about Soviet military capabilities. The best photographs the United States possessed of Soviet territory were images captured by the German Luftwaffe during the war, covering only land west of the Ural Mountains. Everything east of that line, the vast industrial heartland where the Soviets were believed to be building nuclear weapons and ballistic missiles, was a complete blank. The fear was existential. American military planners believed the Soviet Union might be building enough bombers and missiles to launch a devastating first strike. This fear had a name: the missile gap. And the terrifying part was that nobody knew whether it was real, because nobody could see behind the curtain. Existing reconnaissance aircraft, the Boeing 47 and the Martin 57, could photograph Soviet border regions, but could not penetrate deep into Soviet airspace. They flew too low. Soviet interceptors could reach them. Several were shot down. Spying on the Soviet Union from the air was not just difficult. It was lethal. In 1953, the United States Air Force issued a classified requirement for a new aircraft that could fly above 70,000 feet, beyond the estimated ceiling of any Soviet fighter, missile, or radar system, and cover 3,000 miles carrying cameras capable of resolving objects as small as 2.5 feet on the ground. The aircraft needed to be cheap, fast to produce, and expendable. One man answered the call, and what he delivered changed the course of history. Clarence Leonard Johnson, known universally as Kelly, was the chief engineer at the Lockheed Corporation's Advanced Development Projects Division in Burbank, California, nicknamed the Skunk Works. Kelly handpicked his engineers. He kept the team small, rarely more than a few dozen people. He eliminated bureaucracy. He demanded that designers sit on the factory floor next to the machinists building the parts, and he worked at a speed that the Pentagon considered impossible. The Air Force initially rejected Kelly Johnson's proposal, but the design caught the attention of Edwin Land, the inventor of instant photography, who sat on a presidential advisory panel. Land brought the concept directly to the director of the Central Intelligence Agency, Allen Dulles, who brought it to President Dwight Eisenhower. Eisenhower approved the program on the condition that it be run not by the Air Force, but by the agency in total secrecy. The project was given the classified code name Aquatone. Now here is where the engineering becomes remarkable. Kelly Johnson's design merged the fuselage of his own F-104 starfighter with the wings of a sailplane. The result was an aircraft 63 feet long with a wingspan of 80 feet, powered by a single Pratt & Whitney J57 turbojet. To save weight, Johnson eliminated almost everything a conventional aircraft carries. The landing gear was reduced to 2 wheels on the center line, with small detachable outrigger wheels called pogos that fell away on a takeoff. When the aircraft landed, one wingtip would eventually scrape the runway, and the plane would pivot to a stop like a top winding down. It weighed roughly 7,300 pounds empty. It could carry up to 3,000 pounds of cameras and sensors. Its fuel capacity allowed missions lasting 6 to 8 hours over distances exceeding 3,000 miles, and it could cruise above 70,000 feet, higher than any aircraft in operational service anywhere in the world. If you are beginning to understand how audacious this was, subscribe, because the story of what happened next is even more extraordinary. From contract to first flight, it took 8 months. 8 months. Kelly Johnson delivered the aircraft to the agency on schedule, on budget, and ready to fly. The first test flight took place at a remote facility in the Nevada desert known internally as Paradise Ranch and later known as Area 51 on restricted airspace maps. Tony Livier made the first flight in August of 1955. The aircraft was so eager to fly that it became airborne accidentally during a high-speed taxi test, before the official first flight was even scheduled. The first operational mission over the Soviet Union was flown on July 4, 1956. Within hours, the cameras had photographed Soviet airfields, missile installations, and industrial complexes with a resolution that stunned analysts. A single mission could photograph a strip of territory roughly 125 miles wide and 3,000 miles long. One aircraft, one pilot, one flight, and the intelligence community had more information about Soviet military capability than it had gathered in the previous decade. Stay with this, because the implications reshaped the entire Cold War. The photographs proved that the missile gap was a myth. The intelligence gathered allowed President Eisenhower to resist enormous pressure to accelerate nuclear weapons production. Without those photographs, the arms race could have escalated far beyond what actually occurred. The aircraft did not fire a single shot. It may have prevented millions of deaths simply by showing American leaders what was actually on the ground. But there was a catch. The Soviets knew the aircraft was there. From the very first overflight, Soviet radar tracked it. Soviet fighters scrambled to intercept. They could see it at 70,000 feet, but they could not reach it. No fighter could climb high enough. No missile had the altitude capability. For 4 years, the aircraft operated with near impunity while Soviet air defense commanders watched helplessly from below. Eisenhower understood that the overflights could trigger a war if an aircraft were ever brought down. He authorized each mission personally. On May 1st, 1960, the gamble was lost. Francis Gary Powers took off from a base in Peshawar, Pakistan, on a route that would carry him across the Soviet Union to Norway. 4.5 hours into the flight, at approximately 67,000 feet over the city of Sverdlovsk, a volley of 14 Soviet surface-to-air missiles was launched at his aircraft. The missiles could not reach the aircraft's altitude directly, but the shock waves from their detonations tore the aircraft apart. Powers ejected, parachuted to the ground and was captured. The Eisenhower administration, believing the pilot was dead and the aircraft destroyed, activated a cover story. They announced that a weather research aircraft operated by the National Aeronautics and Space Administration had gone missing over Turkey. Soviet Premier Nikita Khrushchev waited several days, allowing the Americans to commit fully to the lie, and then revealed that the pilot was alive, in custody, and that the Soviets had recovered the camera equipment. The diplomatic humiliation was total. A planned peace summit in Paris collapsed. The brief thaw in Cold War relations evaporated overnight. 2 years later, the same type of aircraft redeemed itself. On October 14, 1962, a pilot named Richard Heiser flew a mission over Cuba and photographed Soviet medium-range ballistic missile installations under construction. Those photographs triggered the Cuban Missile Crisis. For 13 days, the world stood closer to nuclear annihilation than at any other point in history. The photographs that started the crisis were also the photographs that helped resolve it, because they gave American leaders the verifiable intelligence they needed to negotiate from knowledge rather than fear. A total of 104 aircraft were built between 1955 and 1989. The modern variant, redesigned with a more powerful General Electric engine and updated sensors, costs approximately $34 million per unit. It carries synthetic aperture radar, electro-optical reconnaissance systems, and signals intelligence equipment that can transmit data in real time to ground stations and battlefield commanders. The aircraft is still flying. As of 2023, it was used to track a Chinese surveillance balloon crossing the continental United States at high altitude. 7 decades after Kelly Johnson sketched the first design on a drafting table in Burbank, the aircraft he built in 8 months remains in active frontline service with the United States Air Force because satellites pass overhead on predictable orbits and drones cannot survive in contested airspace above 70,000 feet. Flying the aircraft remains one of the most difficult tasks in military aviation. The pilot wears a full pressure suit, identical to those worn by astronauts. The cockpit is unpressurized above the suit. At 70,000 feet, the margin between the aircraft's maximum speed and its stall speed narrows to roughly 10 knots. Fly too fast, and the wings shear off. Fly too slow, and the aircraft drops out of the sky. The pilot spends 90% of a typical mission flying within that 10-knot envelope. For hours alone in a pressure suit, above 99% of the Earth's atmosphere, looking down at a continent that does not know it is being watched. There is a particular silence at 70,000 feet. The engine is behind the pilot. The air is too thin to carry sound in the way it does at lower altitudes. The sky above is nearly black. The curvature of the Earth is visible on the horizon. Below, entire nations pass in silence under the lens of a camera that can read a license plate from the edge of space, mounted in an aircraft designed by a man with a slide rule in a building in Burbank that most of his neighbors did not know existed, doing work that most of his country would not learn about for decades. In an airplane that was supposed to fly for 2 years and is now approaching 70, still climbing, still watching, still the quietest and most consequential machine in the sky.